Now let's examine how these different components inside the CPU work together as one complete unit to run a program. So here we are looking at a program written in the machine language, or the language which the CPU understands. To demonstrate how these instructions in this program are executed, I will walk you through every instruction, showing you what exactly happens inside the CPU. And for this purpose, I have made a very small segment of a program which consists only 6 instructions. This program, of course, will not do any useful processing task. It will simply add two values which are stored in the memory, and then store the result in another memory location, and it will also show what happens when you execute a jump instruction. But it will be sufficient for you to understand how the CPU works in running a program. So before we go into the program, let's look at what are the instructions in our program and what they are expected to do. So let's assume that our small segment of program is loaded starting from memory address 0, 0, 0, 0, all zeros, right? So the very first address in the memory. So the first instruction I'm going to find in that location is a load instruction, which loads the register B with a immediate value following that instruction. So in the 0, 0, 0, 0 location, the very first location, I have the load B opcode, and then in the next memory location following that, I have the data value which need to be loaded to register B. In this case, the data value is 4 zeros, 1 and 3 zeros in binary, which means equivalently in decimal it is 60. Then instruction at the memory address 2, right? Following that, I have another load instruction where the opcode is load C comma a value. And here the value is in the third memory location, which is 3 zeros and a 1 followed by 4 zeros. So the decimal equivalent for that will be 32. In the instruction following that, I have another load instruction, but in this case I load A comma C, right? Which means I load the value of C to register A, right? From register C to register A. Why I need to do that? If you recall our CPU design, the ALU design, to do any operation through the ALU, I need one of the inputs to be in the register A. So one of the two inputs that I am going to add, which is of register B and register C, I need to transfer to register A before I can do the addition operation. And another point you will realize is that the first two instructions, the load B instruction and the load C instruction, occupies two memory locations. One to have the instruction opcode and another one to have the data value. Whereas the load A comma C, which loads the value in the register C into register A, does not require two memory location because it does not have any data value stored in the memory to be used in that instruction. So it occupies only one memory location, which is memory address 4. Then in memory address 5, I have the actual addition instruction. It says add B, which will add the register A to register B. So why I can do that? Now I already have transferred the value of the register C to register A. So what register A is having is value of register C. So when I add that with register B, I get the sum of the two values. Now here I am not specifically saying that the instruction has add A comma B, because for any operation that the ALU is doing, one parameter is always the register A. One input is always the register A. Because of that, I don't need to explicitly say I am adding register A to B, because when I say add, register B is one of the registers, one of the inputs, and the other input has to be register A. And also, based on the design, my output also go into register A. Then I execute in the following instruction a store instruction. In this store instruction is storing the register A in a memory location. So here the memory address is the immediate address following that. So I am storing the sum of the two addition, my last results, which is now in register A in the memory location immediately following that instruction, which is memory location 7, and it will set the value to go there. Now, before I store that value, that memory location has some value, right? Memory always contains some value. So when I execute this instruction, the current value of the memory location 7 will get overwritten by the result of the two instructions. Then finally, I have another instruction at memory address 8 which will show you the jump operation. In this case, the jump operation will jump to a particular address, and in this case the address is given as the address 4, right? So it will if you look at the program at address 4, it has load a comma c. So when it come to instruction 9 at memory address 9, the jump instruction will be executed, and then the program will jump back to load a comma c register, which is at the address 4, and continue from that point onwards. So if you look at this program, the way it operates, it will be repeatedly loading register C to register A and adding that with register B again, and storing that value in the memory location, and it will be repeating that forever, because the jump instruction is unconditional. So each time it comes to instruction number 8, it will jump back to instruction number 4. So the program itself is not doing any useful work, but let's now go through each of the instruction and see what happens at different components of the CPU when the CPU execute these instructions.